We're looking at this question here because it's 8 marks. Allow me to explain. For this 8-mark question, first off, don't make a mistake of just because it's worth 8 marks, you just feel this psychological almost deterrence from like it must be some motherfuckingly difficult question. No, that's not the case. Sometimes it's the case, but at the end of the day, it's worth 8 marks. Don't worry about the number of marks. Focus on, and also, don't make the mistake of when you look at the wording over here, feel like the wording is very difficult to follow. Because at the end of the day, do they give you a diagram, yes or no? This diagram is pretty damn intuitive, isn't it? Because look at this, right? You've got in arcs, like you can tell this is a sector. You're not confused. There's no mistake over here. COD is going to be part of a circle, slice of a circle, cheese slice. Another cheese slice over here, ABC, another sector of a circle, radius 5. Point is this, remember the protocol for these types of questions? Even if you didn't know how to do the math, even if you had no fucking clue what the area of a triangle is or area of a sector is, you know how to find the area of the shaded region, isn't it? As in primary school logic over here, if you want to apply it. What even makes up the area of the shaded region? Do you see, that's what we wrote down for the first line of working over here. This first line of working is really just explaining. Area is going to be equal to the triangle AOB, sector AOB. AOB, see this line of working over here? A is equal to, ignore this one over here, I should cross that one out. But A is equal to triangle AOB. This is our first line of working. AOB, the full triangle, minus the sector COD, minus this cheese slice, minus the ABC over here. Do you see my point? The first step over here, really, in terms of how you think about the question to solve it, it didn't really involve math, did it? It was a visual question. Yes, this is visual logic over here. The visual logic over here, primary school logic, you could do it. Now, my point is this. Once you have that, isn't it much easier for an 8-mark question to individually assess this? Do you see the protocol you apply for these types of questions? No matter how many components there are, you just assess the components bit by bit. After you do the very, very first step, which is setting it up, knowing what even makes up your overall final answer, and then you individually evaluate. Well, how about let's find the area of this triangle then? Area of the triangle, remember the protocol, whatever information you can see can be labeled on there, but they don't tell you to label, go ahead and label it on there, because it's going to only make the question easier to do. More detail, better. So you look at triangle AOB. Triangle AOB, do you realize this is the height? This is just the base that we need to find. So let's go ahead and find the base. Oh, wow, it's part of a SOHCAHTOA scenario. See what we did over here, SOHCAHTOA. Opposite over adjacent. So that's very easy to work out. X is equal to, move x to the left, means we move tan to the right, 5 divided by 10 of this. Do not make the radians mistake. Right, make sure your calculator's in radians modes, and then you have 6.8819. Remember the protocol over here also, 4 decimal places at least. Okay, 4 decimal places to be accurate enough. Otherwise you'll lose marks for working accuracy. So once you got 6.8819, you just multiply that by a half based on this height. That's primary school algebra, isn't it? Basic triangle formula, a half, this times 5. So you do not have that. Easy, assembled. Then you move on to sector COD. See that, like, while working over here, it's very, very clearly labeled, right? Very methodical. It's like painting a picture. Right, writing a series of instructions over here. Now you just see COD, we're evaluating this. Why is this working method superior, by the way? Because if you're working under pressure, which you will be, this is a very foolproof method to not lose track of anything, is it? It's all clearly labeled. And you'll see how this perfectly fits in at the end, because look at this sector COD, or let's look at COD. We're clearly missing what? We know from the formula sheet a half theta r squared. Oh, we got theta, we don't have r. How do we find r? Oh, wait, r is going to be this distance, which is very useless from O to D. How the fuck are we going to know where O to D is? Isn't it much easier to find where O to C is? Because O to C is going to be the hypotenuse minus the 5 over here. We realize A to C is also 5. In the actual exam, you would have already labeled by now A and C as a 5 centimeters also, right? Remember from that habit when you look at these questions? They don't tell you this is 5, but you know it's 5, so why don't you go ahead and label that's 5? So in the actual exam, when you see this is 5 and you want to find O to C because you recognize that's also the radius, which will help you for the question to find sector COD, the area of this slice, oh wow, we just do hypotenuse minus 5, which is what we did over here. Hypotenuse, see, radius is equal to OC. Where's OC? OC is over here, which is equal to OA minus 5. OA is the hypotenuse minus 5. So let's find the hypotenuse. Well, we already know this is 5. This is going to be, what, 6.8819 that we worked out from before, from the previous part for AOB. So that squared plus 5 squared square root of that, which is what we did over here. 5 squared plus that minus 5. 4 decimal places. So now we have the area of that sector now, isn't it? A half theta r squared. Done. 3.8628. Last part, sector ABC. This one's the easiest one, isn't it? Because it's going to be a half theta r squared. So a half theta times 5 squared. A half, what's theta? Theta is all, we don't have that, but do we need to be told? 90 degrees plus this angle, plus this has to be 180. Pi minus a half pi minus 1 over 5 pi gives us this. We're dealing with radians, right? Remember the rule has to be in radians. Do not make the fucking mistake doing 180 minus 90 minus this. That's retarded now, isn't it? Do not make the mistake doing pi minus 90 minus this. They all had to be in the same units. It must be consistent units across the board. Radians over here. Pi radians, 180 degrees minus this, minus a half pi, because 90 degrees is a half pi. That's how you're going to find this angle over here. And that's going to be the angle you substitute in for a half theta r squared. Formula sheet, sector area. Pi minus a half pi minus this. We've written that in. We just substitute that in for direct formula. See how easy this is? This might look like long working, but it's just substituting numbers in for the instructions over there that we know for a fact will give us the area of a sector, ABC. Write that in, exact number on your calculator, and then last part, look how easy it is. Primary school logic now, isn't it? Triangle minus these two sectors, or what's the triangle? We've got that already written over here, 17.2048 minus the 3.8628 minus the 15 over 4 pi, and that's going to be 1.56 centimeters squared. The working over there doesn't include the pi, but you know there's a pi over there. You get my point. The final answer is 1.56 centimeters squared.